Yes, once again, thank you, Amanda and Nathan, for inviting me here to do this and giving me this opportunity. I really appreciate it. As I mentioned to you, Amanda, DORA is and sort of software engineering performance and metrics are a bit of a passion of mine, so it's lovely to be in this group and talking about this topic. As you mentioned, I am the creator of a web app called Fermionics, which does DORA metrics tracking. So I'll just set a few expectations. I think it's been noted in the meeting invite already, but this will be a fairly short presentation. Brevity is the cornerstone of wit, as they say. And what I will present today is actually some real data. It's been anonymized, but real data from one of the users of Fermionics here in the sunny city of Perth. So without further ado, I'll go ahead. Oh, there's my thank you slide. Right. So we've been using this user of Fermionics has been using DORA metrics for about 18 months now and tracking them consistently across all their technical ecosystem, their deployables. And a little while ago, we were chatting, and we wondered, can DORA metrics be used to calculate some kind of return on investment on technical investments? And what I mean by technical investments is something that you might see in the Google technical catalog, automated testing or improved DevOps and that kind of thing. We came up with the answer, which was maybe. We weren't sure. So we thought we'd give it a try. And we came up with two ideas. These are both ideas based upon the lead time to change metric. There may be other calculations you could imagine or perform on the other DORA metrics. But the first one is we call delayed value cost. And the second one is total saved against a baseline. And I'll give you a demonstration of both of these. So first of all, delayed value cost. So the theory here is that otherwise completed but unreleased code or work is yielding no benefit and no return for the company. So we looked at a particular project within this technical ecosystem, and we analyzed the time between what we consider to be completion and release, and then conducted a technical upgrade to the testing process effectively to automate it, and looked at the results. So you can see that here in this chart. On the left-hand side of the screen, we see lots of delayed value, and this is where a lot of testing was manual. We had a very cumbersome QA process. The middle bit is where we stopped, and we effectively released a lot less frequently, but we're able to put in these new testing techniques and DevOps techniques, release automation, I should say. And then, as you can see on the right-hand side, we get a lot less delay. And we express this on the y-axis as delayed value cost, where effectively we proxy, we sort of assign a value to a release or the cost of running a team, and that's how we determine what the delayed value cost would be. And as you can see on the right-hand side, it's much lower. The second example that we have is total saved against a baseline. So in other words, what is the cost of doing nothing? And I think this conversation comes up a lot in DevOps circles when you're arguing to perform some kind of improvement that is very technical in nature rather than feature-based or product in nature. So what we did, we looked at, again, another project over a span of time, and we determined what the average cost of a change was based upon the cost of running a team. So that's the first thing here. It's around almost 15,000. This is Australian dollars. After we conducted our improvements, so the span of time here is 151 days. We got the cost of change down to 3,700. If we had done nothing and stayed at our baseline, the total number of changes at the initial cost would have cost us this much money, so $3.7 million. And afterwards, with the new cost, we're talking about less than $1 million in terms of the cost of change, which is around a 400% improvement. These calculations are, I will admit, very plain. There's a lot of assumptions in them, and there's not a lot of science. But I believe they do speak to some kind of reality. There's probably some improvements here. You could, for example, in this case, when you're quantifying the cost of change, you could potentially perform some kind of categorization in terms of small, medium, large, or something like that. We didn't do that here, but it still gives you some kind of indication of what you might yield when you undertake some of these technical endeavors. And that is all she wrote. Essentially, that's just a very quick rundown of what we did at this place. Thank you, Amanda, again, and Nathan for inviting me here to do that. And I conclude my presentation.